Adhering to the National Electrical Code, or NEC, is crucial for electrical safety. The NEC serves as the minimum standard for electrical installations in the United States and represents a legally binding document for electrical workers. Regarding insulation types, the NEC provides specific tables outlining acceptable options for electrical wiring. Using insulation not explicitly listed in a relevant NEC table constitutes a violation of the code. This requirement ensures that electrical systems operate safely and reliably, minimizing the risk of fire, electrical shock, and other hazards. The NEC table lists insulation types based on factors such as temperature rating, conductor material, and suitability for different environments. These factors are critical for ensuring the insulation can withstand the operating conditions of the electrical system without degrading or failing. Failure to comply with the NEC insulation requirements can result in significant consequences. Firstly, it can lead to unsafe electrical conditions, increasing the risk of electrical hazards for individuals working with or near the electrical system. Secondly, it can result in fines, penalties, and legal liabilities for the installer or contractor responsible for the non-compliant installation. Thirdly, it can invalidate insurance coverage in the event of an electrical incident. To ensure compliance, electrical workers should always consult the most recent version of the NEC and carefully review the insulation tables. It is important to select insulation types that are appropriate for the specific application and operating conditions. If there is any uncertainty about the correct insulation type to use, it is always best to consult with a qualified electrical engineer or inspector. The NEC specifies numerous types of insulation, each with distinct characteristics and applications. Some common insulation types include THHN, THWN, XHHW, and UF. THHN, or thermoplastic high heat resistant nylon covered insulation, is commonly used for general purpose wiring in dry locations. It has a temperature rating of 90 degrees Celsius in dry locations. THWN, or thermoplastic heat and water resistant nylon covered insulation, is suitable for both wet and dry locations. It also has a temperature rating of 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations. XHHW, or cross-linked polyethylene high heat resistant water resistant insulation, offers excellent resistance to heat and moisture. It can be used in both wet and dry locations and has a temperature rating of 90 degrees Celsius. UF, or underground feeder cable, is designed for direct burial applications. It is moisture resistant and sunlight resistant, making it suitable for underground wiring. When selecting insulation, it is essential to consider the ambient temperature, the conductor temperature, and the presence of moisture or other environmental factors. The NEC provides detailed guidance on dating conductor ampacity based on these factors. Dating refers to reducing the allowable current carrying capacity of a conductor to prevent overheating. For example, if a conductor is installed in an area with a high ambient temperature, its ampacity must be derated to prevent the insulation from degrading. Similarly, if a conductor is bundled with other conductors, its ampacity must be derated to account for the increased heat generated by the bundle. The NEC also specifies requirements for the installation of electrical wiring. These requirements cover topics such as conduit fill, support spacing, and protection against physical damage. Conduit fill refers to the percentage of the conduit's cross-sectional area that is occupied by conductors. The NEC limits the conduit fill to prevent overheating and to ensure that conductors can be easily pulled through the conduit. Support spacing refers to the distance between supports for electrical wiring. The NEC specifies maximum support spacing to prevent conductors from setting or becoming damaged. Protection against physical damage refers to measures taken to protect electrical wiring from physical damage. This can include using conduit, raceways, or other protective measures. In addition to the NEC, other standards and regulations may apply to electrical installations. These can include local building codes, state electrical codes, and industry standards. It is important to be familiar with all applicable standards and regulations before starting any electrical work. Failure to comply with these requirements can result in delays, fines, and legal liabilities. Furthermore, electrical workers should receive proper training and certification to ensure they have the knowledge and skills necessary to perform electrical work safely and effectively. This training should cover topics such as electrical theory, wiring methods, safety procedures, and code compliance. Continuing education is also important to stay up to date on the latest changes to the NEC and other relevant standards. When working with electrical systems, it is always important to prioritize safety. This includes wearing appropriate personal protective equipment such as safety glasses, gloves, and insulated tools. It also includes following lockout/tagout procedures to de-energize electrical circuits before working on them. Lockout/tagout procedures involve disconnecting the power supply to a circuit and attaching a lock and tag to the disconnect switch to prevent accidental re-energization. These procedures are essential for preventing electrical shock and other injuries. Furthermore, it is important to use properly rated test equipment to verify that circuits are de-energized before working on them. This includes using a voltmeter to check for voltage and an ammeter to check for current. Never assume that a circuit is de-energized without verifying it with test equipment. In summary, compliance with the NEC installation requirements is critical for ensuring electrical safety and preventing violations. Electrical workers should always consult the most recent version of the NEC, select appropriate installation types, and follow proper installation procedures. Prioritizing safety and obtaining proper training are also essential for working with electrical systems. Remember that the NEC is a living document that is updated every 3 years. It is important to stay informed of the latest changes to the code to ensure compliance. The NEC is developed by the National Fire Protection Association, or NFPA, through a consensus-based process. This process involves input from a wide range of stakeholders, including electrical engineers, contractors, inspectors, and manufacturers. The goal of the NEC is to provide a comprehensive set of rules for the safe installation of electrical systems. While the NEC is the minimum standard for electrical safety, many jurisdictions have adopted stricter requirements. These local amendments may address specific hazards or conditions that are unique to the area. It is important to be aware of any local amendments that apply to your work. In addition to the NEC, other resources can help electrical workers stay informed about electrical safety. These include trade publications, industry associations, and online forums. These resources can provide valuable information about new technologies, best practices, and code updates. When working on electrical projects, it is always a good idea to consult with a qualified electrical engineer or inspector. These professionals can provide expert guidance on code compliance and help ensure that the project is completed safely and effectively. They can also help identify potential hazards and recommend appropriate mitigation measures. Electrical work is inherently dangerous, and it is important to take all necessary precautions to protect yourself and others. By following the NEC, prioritizing safety, and seeking expert guidance, you can help ensure that electrical installations are safe and reliable. Remember, the goal is not just to meet the minimum requirements of the code, but to exceed them whenever possible to create the safest possible environment. The NEC provides detailed tables that specify the allowable ampacity of conductors based on their size, insulation type, and ambient temperature. Ampacity refers to the maximum current that a conductor can carry continuously without exceeding its temperature rating. It is important to select conductors with sufficient ampacity to handle the expected load. The NEC also provides guidance on calculating voltage drop in electrical circuits. Voltage drop refers to the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. The NEC includes requirements for grounding and bonding electrical systems. Grounding refers to connecting the electrical system to the earth to provide a path for fault current. Bonding refers to connecting all metal parts of the electrical system together to create a low impedance path for fault current. Proper grounding and bonding are essential for preventing electrical shock and ensuring the safe operation of electrical equipment. The NEC also addresses the use of surge protective devices, or SPDs. SPD are designed to protect electrical equipment from voltage surges caused by lightning, switching operations, or other events. The NEC requires the use of SPD in certain applications, such as dwelling units and critical facilities. The NEC includes requirements for the installation of electrical equipment in hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present. The NEC specifies special wiring methods and equipment for use in these locations to prevent explosions and fires. The NEC also addresses the installation of renewable energy systems such as solar photovoltaic, or PV, systems and wind turbines. The NEC provides requirements for the safe interconnection of these systems to the electrical grid. The NEC is a complex and comprehensive document, and it is important to have a thorough understanding of its requirements before performing any electrical work. Continuing education and professional development are essential for staying up to date on the latest changes to the code and best practices. By following the NEC and prioritizing safety, electrical workers can help ensure that electrical installations are safe, reliable, and compliant. Remember, electrical safety is everyone's responsibility, and it is important to take all necessary precautions to protect yourself and others from electrical hazards. The specific table that you are referencing dictates the acceptable insulation types for conductors used in electrical wiring based on the 1999 NEC. The table likely includes information such as the insulation type designation, temperature rating, and suitability for wet or dry locations. If you use an insulation type not listed, you are deviating from the code's prescribed safety standards. It's not only about the insulation's ability to prevent shorts. The NEC listed insulations have undergone testing to ensure their longevity, resistance to environmental factors, and overall safety when installed and used according to code. Using unlisted insulation introduces uncertainty about its performance and could compromise the entire electrical system's integrity. Using unlisted insulation could have impacts on things like heat dissipation. The listed insulation types have known heat dissipation characteristics. Using an unlisted type may lead to overheating of the conductor and surrounding materials, especially under heavy loads. This can degrade the insulation itself, creating a fire hazard. Chemical compatibility with other materials is also a consideration. The NEC listed insulations are known to be compatible with commonly used wiring components and building materials. An unlisted insulation might react negatively with other substances, leading to corrosion, breakdown of the insulation, or even the release of harmful chemicals. Mechanical protection is another aspect. While not the primary purpose, the insulation does provide some level of mechanical protection to the conductor. Unlisted insulation may not offer the same level of protection against abrasion, impact, or other physical stresses, potentially leading to damage and electrical faults. In damp or wet environments, the insulation's resistance to moisture penetration is critical. NEC listed insulations for wet locations have been tested and approved for their ability to resist moisture. Using an unlisted insulation in such environments could lead to water ingress, causing corrosion, shorts, and ground faults. It is imperative to consult the latest edition of the NEC and any applicable local codes for the most up-to-date requirements and approved insulation types. The code is regularly revised to incorporate new technologies, address emerging safety concerns, and reflect advancements in electrical practices. Ignoring these updates and relying on outdated information can lead to violations and potentially dangerous situations.